Good day guys, welcome to my YouTube channel, and in today's video I'm going to be solving a past question of Maths 102 of 2017-2018 version of Ekiti State University. So we are going to be moving on in this past question. Don't forget to like, subscribe and share the videos to your friends to let them benefit from my channel. So now we are moving on. The question 1A in the past question says define the following terms: I null vector, I equal vector, then it says we should divide. Let us start with the null vector. Now the null vector is any vector that has a magnitude of 0. The null vector is any vector that has a magnitude of 0. That is the simple definition. Then the equal vectors are two or more vector that has the same magnitude and direction. That is what an equal vector is. Then moving on, we have the non-localized vector. The non-localized vector, also known as free vector, are vector that are only measured by their magnitude and direction. That is, they are only measured by their magnitude and direction. They are more of like free vectors. So then we move on to bound vector. Now, bound vector are vector that are only felt in a straight line or at a particular area. For example, force. Force is a very good example of a bound vector. Then also that we have point located vector. Point located vector is the type of vector that is only felt at a particular point. Then up to the modulus of a vector. A modulus of a vector is simply the measure of length of a vector or the magnitude of a vector. So now the question 1B says, with the aid of a well-labeled diagram, state the triangle law of vector addition. Now it says with the aid of a well-labeled diagram, I should state the triangle law of vector addition. Now the triangle law of vector addition goes like this. Let's say we have a line of A to B, line and line B that is moving in this direction. Then I have another line B to C that is also moving in this direction. Now A to C here, A to C, from A to C like this, that is line AC is equals to line AB plus line BC. Now this is the triangle law of vector addition. So now the question 2A in the past question says that differentiate between collinear and coplanar vectors, then find the sum of the following vectors minus BA, BC, minus AD and 2CD. So now differentiating between collinear and coplanar vector. Now collinear vectors are vectors that are parallel to the same line, while coplanar vectors are vectors that are parallel to the same plane. That is it for collinear vector and coplanar vector. Now moving to the calculation here, find the sum of the following minus BA, BC, minus AD and 2CD. So we have since we are adding up, we have minus BA then plus CD then plus what we have here is minus DA plus minus DA, then we have our plus 2CD. Now 2CD can also be written as CD plus CD, the same thing as 2CDs. So now if we try to bring this, minus BA is the same thing as AB according to vector. So we have this as AB, line AB, then plus this is BC, sorry, this is BC, line AB plus line BC, then this minus DA here is the same thing as AD, or we can try to leave it as D anyhow, or we can change it to AD. So we have plus AD, then here we have plus CD, then we have plus CD. So now if we add it together using triangle law, we have AB plus BC is equals to AC. So we have AB plus BC is equals to AC, then we have plus AD plus CD plus another CD. If I try to add up again now, AC plus CD can go. We have AC plus CD. AC plus CD is equals to AD. We have AC plus CD. We have AD plus this AD here plus AD plus CD. Now if we add AD and AD together, it is going to give us 0, because it's just like saying AD can be written as minus DA. So it will now be AD minus DA, which will give us 0. So AD here has gone with AD. So our final answer is equals to CD. So this is our final answer. So in the question 2b of the past question, it says that in the Cartesian system, given the vector line A is equals to 36i plus 26j, line B is equals to 8i minus 2j, and line C is equals to 4i plus 6j. Express line A as a linear combination of line B and line C. So what they are expecting us to do here is expressing line A as a linear combination of line B. That means there will be a component multiplied by B, then another component multiplied by C. So what we are going to be looking for here is x and y, then we are going to be expressing it in this form in order to get our answer. So now what is our value for A? 36i plus 26j. So we have 36i plus 26j is equals to x, then open your bracket. Our B here is 8i minus 2j, then plus y, open bracket. Our C here is 4i plus 6j. So now if we expand this, we have 8x of I minus 2x of j plus 4y of I and plus 6y of j. I just expanded the bracket. Is equals to 36i plus 26j. So now I'm going to try to bring all the I component and the j component together so that we do not make a mistake here. So let me put 8x of I, then plus 4y of I at one place. Then I put my j minus 2x of j, and I put my plus 6y of j. So now this is equals to 36i plus 26j right here. So now after we have done this, we are going to try to like pick the ones that are similar. Now the value for I on this side is 36. The value for I on this side is 8x plus 4y. So we bring it out. We have here 36 is equals to 8x plus 4y. 8x plus 4y. While on the second side we have 26 is equals to 4y minus 2x plus 6y. That is minus 2x plus 6y. So now these are the two equations that we are going to be bringing out, equation 1 and equation 2. So from any one, we are going to bring out a third equation, making maybe either x or y the subject of the formula. So me, I'm picking my equation out of number 2. So out of number 2, I'm going to be bringing out x as the subject of formula. So I'll be bringing my 6y to this other place. We have here 26 minus 6y is equals to minus 2x. So that is it now. Divide both sides by minus 2. Minus 2 cancel this minus 2 here. why the minus comes here? 2 here 1, 2 in 26 is 13, and 2 in 6 is 3. So here we have a final of 3 13 minus 3y, all in bracket. This minus here is going to come up, so we have our bracket here, we put our minus, is equals to our x here. So therefore our x here is equals to, we bring out the bracket, we have 3y minus 13. So this is the third equation that I was talking about. So now what we are going to be doing is, we are going to be imputing the equation we brought out from the second one, putting it into the third one. So anywhere we see x, we put 3y minus 13. So in the third one we have 36 plus 36 is equals to 8. Now x is equals to 3y minus 13. So we have open brackets 3y minus 13, then plus 4y. So we have 36 is equals to 8 times 3. 8 times 3 is equals to 24y minus 8 times 13, that is equals to 104. So we have minus 104, then plus 4y. We make we find for we collect like terms. We have 36, we have 104. When we bring 104 to this side, we have 36 plus 104 is equals to 24y plus 4y. So now 104 plus 36, that is equals to 31, 34, that is equals to 140. 140 is equals to 28y. If we divide both sides by 28, we are going to get 5. So here we are going to get 5. That means our y here is equals to 5. So now we have gotten our y here equals to 5. So now let us find for our x. Now using this third equation that is here, we have our x as 3y minus 13, but our y is equals to 5. So therefore we have x is equals to 3 times, open our bracket of 5, then minus 13. So we have equals to 3 times 5, 15 minus 13. Therefore x is equals to 2. So we have gotten our value for x and our value for y. Now we are coming back to our equation here. So we are going to be writing it as line A. We have our x equals to 2. We have line A here is equals to, x now is equals to 2. 2 times line B plus y is equals to 5. 5 times line C. So this here is our final answer for the question that we have here. So now the question 3b of the past question state that determine whether the two lines R of a line RA 4i plus 2j minus 6k plus t open bracket minus 8i plus j minus 2k and R of B, that is line B, of minus 2i plus j minus 2k plus s open bracket minus 9i plus 2j minus 5k meets. Hence find the point of intersection. Now what I want you to know here is that where the points meet, like the point between where two lines meet, the equation, like the answer of the equation will be equals to each other. That is, both of them will be equals to each other. So therefore if at point of intersection we have R of A is equals to R of B. This is the point of intersection. So if R of A is equal to R of B, first of all let me expand my R of A first. So we have my R of A line A equals to 4i plus 2j minus 6k plus, now I'm going to expand it with this t. So we have this t here to be minus, let me put it inside the bracket. We have minus 8ti then plus tj then minus 2t then we have our k. So this is for Ra, and if I expand a little bit more, I have if I expand a little bit more, let's say I remove the bracket right here, the minus times plus will be equals to minus. So directly here we are going to be having our minus. So that is just like that. So now I'm going to be picking the value of I, I'm going to be putting them together. The one with I, I'm putting them together, we have equals to, we have 4i then minus 8ti. Then for j we have plus 2j, we have plus tj. For k we have minus 6k, and here we have minus 2tk. So that is for R of A, line R of A. Now moving to line R of B. Line R of B is equals to this minus 2i, we have plus j minus 2k. Then here if I open the bracket, s times minus 9i, we have minus 9si. We have s times 2j, we have plus 2sj. S times minus 5k, we have minus 5sk. 5sk. So now we do the same thing as we do for here. Our R of B is equals to the one with I, bring them to closer. We have minus 2i minus 9si. Then one of j, we bring them together, plus j, then we have plus 2sj. Then with the one of k, we have minus 2k. Then here we have minus 5sk. Minus 2j minus 5sk. So now this is how it will be. Now remember I said earlier that at the point of intersection, R of A will be equals to RB. So now if R of A is equals to RB, that means the I component is equals to the I component here. The j component here will be equals to the j component here. And the k component here will be equals to the k component here. So that means, what is the I component here? The I component here is 4i minus 8ti. So we bring out those constants there. So at first we have 4 minus 8t is equals to, then on the b side the one of I is equals to minus 2 and minus 9. So we have minus 2 minus 9s. We can keep this as equation 1. Then we also pick from j, pick from k. So we continue that way. From j we have our 2 plus t is equals to, then in the k aspect we have 1 plus 2s. 1 plus 2s, we can keep that as equation 2. Then on the third side we have k minus 6k and minus 2tk. So we have minus 6 and minus 2t is equals to, on this side we have minus 2 minus 5s. So obviously here we are going to be looking for the value of t and the value of s. Then we bring out that equation. That equation is going to be our point of intersection. So let me make a little space. So now I'm going to pick any of the ones here, and I'm going to try using substitution method. So let me pick this number 2 right here and make t the subject of the formula. So from this second one right here, if I make t the subject of the formula, I am having t is equals to 1 plus 2s. And if this 2 comes to the other side, we have minus 2. So therefore our t is equals to minus 2 plus 1, that is equals to minus 1. We have 2s minus 1. So this is our value for t. Let me write it down. T is equals to 2s minus 1. So wherever we see, let's put this equation 4. So wherever we see our t, we know that t is equals to 2s minus 1. So now let's go to another equation. Let's say equation 1 or equation 3, whichever that is befitting, but I'll pick equation 1. So I have 4 minus 8 in brackets. I have my value for t here, which is 2s minus 1. Then I close my brackets. Then equals to minus 2, then minus 9s. So now I expand my bracket. I have 4 minus 8 times 2, we have minus 16s. Minus 8 times minus 1, we have plus 8, equals to minus 2 minus 9s. So what do we do here? What we do here is we collect the like terms. So I would like to bring my s here and bring my constant for this other way. So we have 4 plus 8, then minus 2 comes here, becomes plus 2 here, then plus 2, that is equals to, I bring my minus 16s to this other side. I have plus, that is 16s with my minus 9s. So I get this 4 plus 8 12, 12 plus 2 14. So 14 is equals to 16s minus 9s, we have 7s. Divide both sides by 7. 7 cancel 7. 7 here is 2. Therefore s is equals to 2. So the first thing, we have forgotten our value for s. S is equals to 2. We can decide to continue like this, but for the sake of this, we have, let's find for the value of t right here. So now looking for the value of t, our value, we wrote our t down here as t is equal to 2s minus 1. So we have t is equals to 2, our s here is equals to 2, that is 2 here minus 1. So therefore our t is equals to 4 minus 1, t is equals to 3. So the meaning of this is that if you put t equals to 3 into this equation, you are going to get the same equation as when we put s equals to 2 into this equation. So we are just going to pick any one of this equation and we are going to put any one that matches with it. So right here, I'll be picking any equation. So I'll pick the second equation, r of b, then I'll be putting my value there. So I have minus 2i plus j minus 2k, then plus s now is equals to 2, open my brackets, minus 9i plus 2j minus 5k. So if I open my bracket, I have minus 2i plus j minus 2k plus, then we expand this here. Let me know the plus sign. We have 2 times minus 9i, that is minus 18i. Then 2 times 2j, that is plus 4j. Then 2 times minus 5k, I have minus 10k. So I just add them together, minus 2i minus 18i minus 20i, then plus j plus 4j, that is plus 5j, minus 2k minus 10k, that is minus 12k. Right here is the point of intersection between these 2 points right here. You will realize that if you use the value of t instead of s, which I used, you are going to get the same answer as which I got. So here the question 3b says that if force F is equals to minus 2I plus 3J plus K as the point of application moves from P to Q, for where PQ is equals to 3I plus J minus 4K. Find the work done. So simple here, they ask us to find the work done. Now note that PQ is the distance from P to Q and it is given by 3I plus J minus 4K. So what you just have to do is work done is equals to force times distance. So we just multiply. So therefore our solution here is force work done is equals to force times distance, that is distance S. So that is equals to force is equals to in bracket minus 2I plus 3J plus K. Then open bracket here we have 3I plus J minus 4K. So here we are going to be doing scalar product. This is a dot product here. So dot product here minus 2 times 3I, that is minus 6. The I is not, the I times I is equals to 1. So we are having this as this is equals to minus 6. Then 3 times 3J times J, that is plus 3. Then we have K times minus 4K, that is minus 4. So if we add this together, this is going to give us equals to minus 7. So the work done is equals to minus 7 units.